Alright. So I guess that was rather easy because we've already been given the function in its factorized form, which makes finding the x-intercepts rather straightforward. Now, in this example, what we're going to do is have a look at how to sketch the graph of a cubic function that's been given to us in its original form. That is, it hasn't been factorized. For example, y equals ax cubed plus bx squared plus cx plus d. Now, in order to be able to find the x-intercepts of this, what we're going to need to do is first of all factorize, because we've got more than one type of x, and then we're going to go through and try and sketch the graph. So let's check out a worked example on how to do just that.
Alright, so this question now says sketch the graph of y equals x cubed plus 6x squared plus 11x plus 6, showing all intercepts with the axis. Now, in order to be able to do this, what we need to do is go through and follow our 4 steps. That is, step 1, find the y-intercept. Now, in order to do that, what we do is we go for y-intercept, x is equal to 0. So we need to go through and write out the equation on the line first of all. So we got y is equal to x cubed plus 6x squared plus 11x plus 6, and we're going to substitute in 0 for x. So we're going to go y is equal to 0 cubed plus 6 times 0 squared plus 11 times 0 plus 6. That's going to get us y is equal to 0 cubed is 0, 0 squared is 0 times 6 is 0, 11 times 0 is 0, therefore you're going to get 6. And the coordinate of the y-intercept therefore is going to be at 0, 6, because our x-coordinate is 0 and our y-coordinate is 6. So what we'll do is we'll go through and highlight that now, just because it's going to be important when we come to sketching it later on. And the next step to do is go through and find our x-intercepts. So for our x-intercepts, we know that that's going to occur at y is equal to 0. So what we're going to do is go through and write out the equation of our line. So we're going to go y is equal to x cubed plus 6x squared plus 11x plus 6. And we're going to substitute in 0 now. So we've got 0 is equal to x cubed plus 6x squared plus 11x plus 6. Now, how many different types of x have we got? Well, we've got 1, 2, 3, because we've got an x cubed, an x squared, and an x. So because we've got more than one type of x, we need to go through and factorize in order to be able to solve. Now, in order to be able to factorize to solve, what we need to do is redefine this as being p of x. So we're going to go p of x is equal to x cubed plus 6x squared plus 11x plus 6. Because we're going to need to be able to substitute in using rules of polynomials. Now, in order to be able to do this, what we need to do is look at the number 6 at the end here, and we need to think about what are the factors of 6 in order to be able to find out what is a factor of p of x. So let's just try, for example, x plus 1. So is x plus 1 a factor of p of x? Well, let's go through and find out. Now, in order to be able to do this, what we need to do is substitute in p of negative 1, and that's going to get us negative 1 cubed plus 6 times a negative 1 squared plus 11 times negative 1 plus 6. That therefore is equal to negative 1 cubed is negative 1 plus 6 times negative 1 squared. Well, negative 1 squared is 1 times 6 is plus 6. Negative 1 times 11 is equal to negative 11 plus 6. That therefore is equal to negative 1 plus 6 is 5, minus 11 is negative 6, plus 6 is equal to 0. Yes, I love it when I get the factor straight off. So therefore x plus 1 is a factor. Now, if we know x plus 1 is a factor, what we can then go through and do is draw out our box. We can write in negative 1 out the front here, because we had x plus 1 as a factor, so we write negative 1. And we go through and we write out the coefficients of p of x. That is 1, 6, 11, and 6. We write plus 0 and a little times out the bottom here. Now we go 1 plus 0 is 1, negative 1 times 1 is negative 1, 6 plus negative 1 is 5, negative 1 times 5 is negative 5, 11 plus negative 5 is 6, negative 1 times 6 is negative 6, and 6 plus negative 6 is equal to 0. This gives us our remainder, this gives us our constant at the end, this is our coefficient of our x, and this is the coefficient of our x squared. So we'll just come up here and continue the question up here like so, and therefore we know that p of x is equal to x plus 1 out the front, because we knew that was a factor, multiplied by our x squared, well it's going to be 1x squared or just x squared, plus 5x plus 6. Now what we need to do is look to factorize our quadratic factor here, which is x squared plus 5x plus 6. Now in order to be able to factorize quadratics, what we need to do is look at the last part here, that is a plus 6. And what are the factors of plus 6? Well, it's going to be 2 and 3. And does 2 and 3 add to 5? Well, yes it does. So we've got p of x is equal to x plus 1, x plus 2, and x plus 3. Now what we need to do is go through and solve for that. So we know that y was equal to 0 and we need to find our x-intercept. So we're going to write 0 is equal to x plus 1, x plus 2, x plus 3. And therefore we go through and we make each factor equal to 0 now in order to be able to solve. So you get x plus 1 is equal to 0, x plus 2 is equal to 0, and x plus 3 is equal to 0. Therefore as x is equal to negative 1, x is equal to negative 2, and x is equal to negative 3. Going through now and putting those coordinates, we've got our x coordinate negative 1 and our y coordinate of 0, x coordinate negative 2 and a y coordinate of 0, and x coordinate negative 3 and a y coordinate of 0. Go through and highlight these now because we're going to need them when sketching the graph in a second. And all we need to do now is continue on with the steps. So it says step 3, plot the points and identify the types of intercepts. Alright, so what we're going to do is plot the point. So it's at 0, 6. So we come up to the coordinate of 0, 6 up here. And we write 0, 6. The next one at negative 1, 0. So negative 1, 0. And we write negative 1, 0 like so. Negative 2, 0. And once again we write negative 2, 0 just as you can see here. And negative 3, 0. Negative 3, 0 like so. Now what we need to do is identify the different types of intercepts that they've got. Now if we have a look here at the most factorized version, we've got p of x is equal to x plus 1, x plus 2, and x plus 3. Now as you can see they're all linear factors, so therefore they're all going to be linear type of intercepts. That is, they're going to go straight through the line rather than being turning points. Now if we have a look at the number at the front of the x cubed in the original question, that is all the way up here, what we can see is that the number at the front of the x cubed is positive, therefore the graph's going to continue going up at the very end. So the last intercept that it has with the x-axis needs to be going up. So we're going to go over to the x-intercept and we're just going to draw the line going up as you can see there. This means if this one's going up, this one here needs to be going down, which means this one needs to be going up, and as you can probably start to imagine in your head, there's a bit of a cubic happening here already. So what we're going to do is just draw in all the dots now. We're going to go up like so, come around, down like so, up, through the point 0, 6, and draw a line. And of course we draw an arrow there like so as well. Go through and write out the equation of the line, that is y is equal to x squared plus 6x plus 11x plus 6, and that there is how you sketch the graph of a cubic polynomial. Alright guys, so it's now time to press pause and attempt the following question, that is sketch the graph of y equals negative x cubed plus x squared plus 14x minus 24, remembering to show all intercepts with the axis. And of course, like always, when you're done, make sure you press play so you can check your solutions out against mine. Alright, so welcome back once again. Now, as I said before, the question says sketch the graph of y equals negative x cubed plus x squared plus 14x minus 24, remembering to show all intercepts with the axis. Now the very first step that I went through and did was I went looking for my y-intercept as it's basically outlined up there in step 1. So to find my y-intercept, I make x equal to 0, and I substitute in getting me negative 0 cubed plus 0 squared plus 14 times 0 minus 24, which ends up getting me y is equal to negative 24, giving me the coordinate 0, negative 24, because my x coordinate was 0 and my y coordinate ended up being negative 24. Now the next step was to go through and find the x-intercepts by making y equal to 0. So as you can see, I've written out the equation of the line here, made y equal to 0 as you can see, and then what I've done is I've redefined y as being p of x, because as you can see here I've got more than one type of x. I've got an x cubed, an x squared and an x. So in order to be able to go through and solve, I need to factorize, and in order to be able to do that I need to work with polynomials. So it's p of x is equal to negative x cubed plus x squared plus 14x minus 24. Now the first step to do when factorising is to take out any common factors. Now as you can see I've got my negative here, so that means I've got p of x is equal to negative bracket x cubed minus x squared minus 14x plus 24. Now in order to continue to go through and factorise, I need to look at the 24 here, and I want to look for factors of 24. So for example I might try, is x minus 2 a factor? So I've gone through and done that. I've written p of 2 is equal to negative bracket 2 cubed, because x cubed, and so instead of writing x I've written 2, minus 2 squared minus 14 times 2 plus 24. Then my 2 cubed has got me 8, my negative 2 squared has got me 4, because it's 2 squared is 4 and the negative out the front. Negative 14 times 2 is negative 28, and plus 24 at the end. 8 minus 4 is 4, negative 28 plus 24 is negative 4, so 4 minus 4 is 0, therefore p of 2 is equal to 0. And because of that we know that x minus 2 is a factor. Now because I know x minus 2 is a factor, what I do is I go through and I get all the coefficients of my p of x. Now I've already partly factorised, so I only get the coefficients of what you can see in the bracket. So coefficient of x cubed is equal to 1, as you can see up here. The coefficient of the negative x squared, well, that's going to be equal to negative 1, so you can see that here. Coefficient of x is equal to negative 14, so I've written negative 14 here, and then you've got 24 as a constant at the end. Going through now, I've got 1 plus 0 is 1, 2 times 1 is 2, negative 1 plus 2 is 1, 2 times 1 is 2, negative 14 plus 2 is negative 12, 2 times negative 12 is negative 24, 24 minus 24 is equal to 0. That therefore gives me my remainder of 0. This here is my constant. I've got 1 being the coefficient of my x, and 1 being the coefficient of my x squared. So when I go through and write this in its factorised form, I get p of x is equal to negative, because I've already taken a negative as a common factor, x minus 2, because I knew that was already a factor, and then I've got x squared plus x minus 12, because I've got x squared plus x minus 12 here. So that all comes down there like so. So now what I've got to do is look to factorise this bracket here. Now it's a quadratic expression with 3 terms and no value for a. So what I need to do is look at the factors of negative 12. That'll add to 1. So the factors of negative 12 are 1 and negative 12, 2 and negative 6, 3 and negative 4, 4 and negative 3, 6 and negative 2, and 12 and negative 1. Which ones are going to add to positive 1? Well, it's going to be 4 minus 3 is equal to positive 1. So you get x plus 4, x minus 3, as you can see. So p of x fully factorised is equal to negative bracket x minus 2, x plus 4, x minus 3 in brackets. Therefore, I've gone through and factorised it. I've rewritten it up here, as you can see. And now what I'm doing is solving. So instead of writing p of x, I'm writing 0, because I'm looking for my x values. And that's going to get me 0 is equal to negative bracket x minus 2, x plus 4, x minus 3. Now in order to solve, I go through and everywhere where I see an x, I make that equal to 0. So I've got x minus 2 is equal to 0, x plus 4 is equal to 0, x minus 3 is equal to 0. Solving now gets me x is equal to 2, x is equal to negative 4, and x is equal to 3. That therefore is going to give me the coordinates, or the x-intercepts, of 2, 0, because my x coordinate was 2, my y was 0, negative 4, 0, and 3, 0. So now all I need to do is go through and plot all of these points, but I'll highlight them first just so I know what I'm looking at. And plotting the points now, let's go to 2, 0, so I'm going to go 2, 0, plot the point, and I write 2, 0. Go to negative 4, 0, so I go to negative 4, 0, and I write the coordinates of the point, negative 4, 0. Go to 3, 0, and I write the coordinates 3, 0. Go to the y coordinate of 0, negative 24, so 0, negative 24, and I'm going to write the coordinate here, 0, negative 24. Now this is kind of hard to imagine how it's going to look, because there's going to be a couple of turning points and we don't exactly know where they're going to be. So what we're going to need to do is we're going to need to use our calculator in order to be able to help us out with this. So what we're going to do is just open that up. Alright, so what we want to do is we want to go into a graphs page. We're just going to click on graphs. That will come the set of axes. Now what we're going to do is we're going to enter in our function, so that is f of x is equal to negative x cubed plus x squared plus 14x minus 24. We now press enter, and as you can see here, the graph actually doesn't really show the whole function. So what we want to do is change the window settings, and we may as well change them to what you can see on the axis that we've got on our piece of paper. So in order to do that, you go menu, we're going to go down to window zoom, window settings, and now we change our x minimum, our y minimum, etc. So our x minimum is going to be at negative 5 based on the axis that you can see on the right hand side of the screen. Our x maximum is at 5. We'll leave our x scale as auto. Our y minimum is going to be at negative 60, and our y maximum is actually at around about 5. So we'll tab down, leave y scale as auto, and we press enter. And now, as you can see here, what we've got is a graph that reflects more what we're looking for. So I'm just going to move this function down here. So I just tap on it and I drag it down. And now what we want to do is we want to find all of our points of interest. So in order to do that, I'm going to go to menu, down to trace, graph trace, and I'll go across all the way to the very left hand side of the graph, scroll all the way over. I'm going to press on 0 there, and it says at negative 4, 0, so we know that that x-intercept was correct that we found. We're going to go all the way over here now, keep going like so, and we're going to get to the point where we say y-intercept. So we press enter, 0, negative 24, so we know we're correct there. Continue along to the point where again where it says 0, enter, 2, 0, so we know that that one was correct. And back to 0, press enter, 3, 0, so once again we know that's correct. Now what we want to do is we want to find out our turning points, and there's a couple of ways you can do it, but we're going to show you by doing this way. So you're going to go menu, you're going to go down to Analyze Graph, you're going to go to a minimum, we're then going to go lower bound, so that is over to this side, go upper bound, press enter, and as you can see here it says the minimum turning point is at negative 1.85, negative 40.1. So let's go through and plot that point on our graph now. So we go over to negative 1.85, which will be around about here, and negative 40.1, so come all the way down to 40.1, and it's going to be roughly around about here. And we write the coordinates of the point in, so negative 1.85 and negative 40.1. Go through and find the maximum turning point now, so we're going to go menu, we're going to go to Analyze Graph once again, we're going to go maximum, go lower bound, which is to the left of it, press enter, over to the right, press enter, and of course we can't see all these things, so I'm just going to move these things away. So as you can see here, this is actually going to be a maximum, so it's 2.52 and 1.63. So in order to do that, we just get our pen over here, we go over to 2.52, which is roughly around here, and 1.63, well that's going to be roughly around there like so. And of course we need to write in the coordinates of our turning point, and I'll just draw a little line like that, and it's going to be 2.52, 1.63. Now that I've got all my points of interest, all I need to do is just sketch the graph so that it looks like what you can see on the CAS calculator. So if we come down here like so, have a turning point there, goes up through the y-intercept here, around another turning point, back down through the x-intercept, and we draw arrows on either end. And of course remember to write out the equation of the line, which is y is equal to negative x cubed plus x squared plus 14x minus 24. And that there is how you sketch the graph of a polynomial going the negative direction, showing all intercepts as well as the turning points.
Alright guys, so thank you very much for tuning in to today's lesson, which is all about how to sketch the graphs of cubic functions. Now of course, like always, make sure you stay tuned for the very next lesson, which is all about how to sketch the graphs of quartic functions. That is, a polynomial with a degree of 4, like what you can see here. Now there's something else I was meant to say. Oh, that's right, of course. Like always, make sure you say hi to your maths teacher for me. Mozzie out.